if velocity is the first derivative of position, acceleration is the rate of change of velocity. So it is either the first derivative of velocity or the second derivative of position. So there's this derivative relationship, right? All of these are rates of change. So when we are asked to find the acceleration, that's the second derivative of position, which is the first derivative of velocity. And we generally use a of t to represent position. Now, again, this is a power rule, so I'm going to take my information from this power, right? This is just a polynomial, and I'm going to apply the power rule. So this is going to end up being 12t minus 14. So that's my acceleration at any time, but my acceleration at t equals 1 would require that I change the notation, and then I'm going to plug in a 1 for t. And the big takeaway here for me is your units. Okay, remember, this is a rate of change of velocity. So if my original velocity was measured in meters per second, then this is meters per second per second. And the way that we write that is meters per second squared. And the understanding of that is very, very important for us, right? We're going to be dealing with units all year, so it's important that we recognize what that acceleration unit is going to look like. The next question asks me for the displacement of the particle. Now, the word displacement is going to be very important, and it's something that we're going to continue to talk about as we get further into the year and talk about more complex calculus topics. But there's a huge difference between displacement and total distance. Displacement, okay, is literally just the change in position. So if I wanted to find the displacement between t equals 0 and t equals 3, I would want to know the position at t equals 0, the position at t equals 3, and then I would want to know what the difference between those two values are. Okay, that's all displacement is going to be. So we're going to go back to our position equation, right? So our original equation, this s of t here, and that's what we're going to use for our displacement. So when I take that s of 0, let's see if I can get here, s of 0, I'm going to plug in a 0 everywhere I see a t, and I'm just going to end up with 5. So that one was pretty simple. But then s of 3, I'm going to have to take that 3 and plug it in. So I'm going to end up with 2 times 3 cubed minus 7 times 3 squared plus 4 times 3 plus 5. So be real careful with your analysis here. Make sure that you don't make a numeric mistake. But this is 27 times 2 is 54, right? And then this is 9 times 7, which is 63. So I've got a negative 9. And then I've got plus 12, and then I've got plus 5. So I'm going to end up with there being a positive 8 here. So that is my displacement, that is my position at t equals 3. So I found my position at 0, I found my position at 3. So what displacement is my ability to find the difference between those. And the order of that difference really does matter because it's going to indicate whether or not my displacement is positive or negative. So remember, when we find the difference, we usually go from the one later, right? Minus, because anytime you subtract, the order matters. So where were you at 3 minus where were you originally? So this is going to end up being 8 minus 5. So you have a movement of 3 units, which is in fact 3 meters in this case. So your displacement is going to be 3 meters, but because it's positive, that means I went 3 meters to the right. And while that's not always significant, it is good for you to be aware that whether or not your displacement is positive or negative does indicate the direction that you went. So this makes sense, right? At t equals 0, I was at 5, and then at t equals 3, I was at 8. So of course I moved 3 units to the right in order to land there. Now, explain the meaning of your answer. Let's go ahead and write out a justification at this point. So we'll say, this is going to be a little longer than I want it to be, but we'll say at t equals 0, let's do add particles position. The particles position, there we go. See if I can get my sentence structure down here. Particles position is at 5 meters. Right? And at t equals 3, the position is at 8 meters, trying to make sure I use my units there. Therefore, the particle moved 3 meters to the right. Now, we're generally not asked to explain displacement very much. It's certainly not a thing that we would have to memorize as far as the steps go, like we do with IVT or MVT, those kinds of situations. But it is good that you would understand what these things mean and what it means in terms of displacement.